Imagine you are trying to predict tomorrow's weather. You check two weather apps. One says there is 70% chance of rain if it's cloudy, and other gives a 50% chance of rain if it's sunny. But here is the twist. You don't even know if tomorrow will be cloudy or sunny. So how do you figure out the actual probability of rain? Welcome to PostNetwork Academy. I am Bindeshwar, and today we will be exploring an essential probability rule used in artificial intelligence, machine learning, data science, and even everyday life, the law of total probability. So what you will learn today? How probability partitions work, the law of total probability, and real world examples. So let's get started. So a set of events E1, E2, E3, E4 is set to represent a partition of the sample space as if EI and E are disjoint, that is equal to phi, that are pairwise disjoint. Now because they are disjoint, so E1 union E2 union E3 union E4, that would be equal to sample space, meaning they cover the entire sample space, and EI are greater than 0. Example, any non-empty event E and its complement E prime. So E intersection E prime, that is E5, and they will make, you can say that they will just generate sample space. If you combine them, so that would be sample space. Now you can see that E1 event, E2 event, E3 event, and E4 event, that partitions S. Let E1, E2, E4 be a partition of sample space S, where obviously Pi are 0. Now then the law of total probability states that probability of event A, that would be equal to summation over I is equal to 1 to 4 P probability of A given EI into P EI. Here 4 may be 5, 6, 7, depends on how many partitions you take. So the steps to derive these results are: the events E1, E2, E3, E4 form a partition of S, meaning they are mutually exclusive and exhaustive. So here you can write A as A intersection E1 union, A intersection E2 union, A intersection E3 union, A intersection A4. Now probability of A you can write like this one, and by the definition of conditional probability you can write P A intersection EI, P A probability of A given EI into P EI. So just replace it, so you will get this law of total probability formula. Now just see the diagram. E1, E2, E3, E4 are events and A is here. So this is the law of total probability representation, where this is the sample space. Now let us see an example. So there are two bags. First bag has 5 red and 6 white balls. Second, 3 red and 4 white balls. And one bag is selected at random and a ball is drawn. First of all, bag is selected, then ball is drawn. Find the probability that ball is red, second ball is white. So see that first of all selecting the first bag. So there are two bags. So probability of event E1 is 1 upon 2 because there are two bags. And the same way probability of event T2, that means selecting the second bag, is also 1 upon 2. And conditional probabilities here, P red ball given E1, that is 5 upon 11. From here you can see that red, white and already first bag, that means E1, that would be 5 upon 11. And probability of white ball given E1 is 6 upon 11. For the second one also, red ball given E2, probability of white ball given E2 is 4 upon 7. Now using the law of total probability, so probability of driving red ball, that would be 1 upon 2, that is E1, and that is probability of red ball given E1 and E2, and probability of, you can say that red ball given E2, so that would be 34 upon 77. The same way probability of driving white ball, so that is probability of selecting E1, and that would be 6 upon 11. E1 probability of selecting E1 into 6 upon 11, that is the probability of white ball given E1, that is the probability of E2, and that is probability of white ball given E2. So we will get 43 upon 77. Now let us see another example. A factory has 3 machines producing outputs. So machine X 3000 units and 1% defective. Machine Y 2500 units and 1.2% defective items. Machine Z 4500 units and 2% defective items. And an item is drawn at random. Find the probability that it is defective. So again there would be use of conditional probabilities and law of total probabilities. So define events. So this one Pex, that is 3000 upon 10,000, because you sum 3, this one, so that will come 3000 plus 2500 plus 4500, this will come 10,000. So probability of defective item, probability of there would be item X, means machine X, so that would be 3000 upon 10,000. In item, if item is selected at random, so that probability would be 3000 upon 10,000. Now the same way P EY 2500 upon 10,000 and P is at 4500 upon 10,000. If an item is selected random, now it is defective, so you have to use conditional probabilities. So it is already given defective item which is on machine X, that is 0.01, defective item on machine Y, that is 0.012, defective item on 0.02. So let us use the law of total probability. So just plug the values here. This is Ex, P, T given Ex, that is P Ey, and that is P D given Ey, that is P Ez, and that is P D given Ez, and that would be 0.015. Let us see example third. So there are two coins, one unbiased and one two-headed coin. A coin is selected at random. Find the probability of getting ahead. So very simple, define events. Selecting unbiased coin, half. Selecting two-headed coin, that is also half. Conditional probabilities P H given even and probability of getting H given E2, that because both sides we have head, that means two-headed coin. So using the law of total probability, that would be 3 upon 4. Here understand, two-headed coin means both side we have head. That's why it is 3 upon 4. Otherwise, if it is half, this one is half, single side head coin. So that would be 1 upon 2. So this was 3 examples. Let us see the fourth example. 3 persons are considered for a principal position with selection probabilities: person 1 4 upon 9, person 2 3 upon 9, person 3 2 upon 9. Probability of introducing co-education. The person 1 will introduce 2 3, their probability. Find the probability that co-education is introduced in the college. Again, these are E1, E2, E3, and these are conditional probabilities. So we can find that probability that co-education is introduced in the college. So see that here using law of total probability. Here 4 upon 9, E1 you can assume that is co-education and introduced by person first. The same one, co-education introduced by person second and by third. So this way we can get the probability of event that co-education is introduced, that is GPA. Now hope you understood the concept. For more resources, you can visit www.postnetwork.co. You can also visit YouTube channel for a playlist and videos. You can connect to Facebook page for a post and videos. You can also follow LinkedIn page of PostNetwork Academy. So hope you understood the concept. Thanks for watching the video.